An object that could be 14 billion years old is approaching our solar system at a staggering 208,000 kilometers per hour, and its trajectory is breaking all the rules. 3I Atlas isn't following some random path through space. Its route appears deliberately calculated, weaving through our solar system in a pattern that seems almost designed rather than accidental. This ancient visitor is moving so fast it can't be captured by the sun's gravity, following a path that originated from the oldest regions of our galaxy. It could be carrying water ice and organic materials that predate our planet itself, making it a pristine time capsule from when the universe was just forming, but with a flight path that's making scientists question whether this is really just a natural cosmic wanderer.
Welcome to Tesla Minds, where we dive deep into the universe's most mind-bending mysteries. Today we're uncovering the incredible secrets of what might be the most important discovery in human history. This cosmic time capsule has already forced NASA to deploy both the James Webb Space Telescope and Spherix for emergency observations, revealed composition ratios that shouldn't exist in nature, and triggered a global race among observatories to capture data before it vanishes forever behind our sun in September 2025. Here's what makes this discovery absolutely extraordinary. Hubble's latest images show a stunning teardrop-shaped cocoon of dust streaming off its nucleus, while Webb's spectroscopy reveals the comet is unusually rich in carbon dioxide, a chemical signature that's rewriting textbooks about early universe chemistry. Recent analysis confirms it could be 7 billion years old, making it 3 billion years older than our entire solar system. But perhaps most puzzling of all, its steady rotation suggests a fairly spherical form rather than the wonky shape of Oumuamua, something that shouldn't be possible for an object that survived billions of years of cosmic bombardment. The discovery gets even stranger when you dive into the technical details. Latest observations reveal it has a 16-hour rotation period, spinning at about 1 meter per second for its estimated 10-kilometer radius, incredibly stable for something that should have been torn apart eons ago. As it continues its journey, it will pass relatively close to Jupiter at 0.36 astronomical units, Mars at 1.5 AU, and Venus at 0.7 AU, a trajectory that seems almost deliberately planned for a grand tour of our solar system's major planets. What has scientists truly baffled is how this ancient wanderer maintains such remarkable consistency. Most interstellar objects tumble chaotically through space, but 3I Atlas rotates with clockwork precision. It will remain visible to ground-based telescopes through September 2025, disappearing as it passes too close to the sun, then reappearing on the other side by early December, giving humanity two crucial observation windows to unlock its secrets. Amateur astronomers worldwide have been capturing unprecedented images of this cosmic visitor, showing activity levels that defy every model we have for comet longevity. Professional observatories from Chile to Hawaii are working around the clock, knowing that this could be our only chance in a lifetime to study something this ancient and mysterious. The data they're collecting isn't just changing our understanding of comets, it's forcing us to reconsider fundamental assumptions about how objects can survive in the hostile environment of interstellar space for geological timescales. On July 1, 2025, NASA's Atlas Survey Telescope in Chile captured something that made astronomers worldwide pause their work. Initially catalogued as A11P L3Z, this object quickly revealed characteristics that defied explanation. It wasn't just another comet, it was a record-breaking visitor that challenges everything we know about survival in space. The discovery became even more intriguing when astronomers realized they had been unknowingly tracking this object for weeks. The Zwicky Transient Facility and other Atlas telescopes had observations dating back to June 14, 2025. This ancient traveler had been silently photobombing our telescopes for nearly a month before anyone realized what they were looking at. What makes this discovery truly unprecedented is that 3I Atlas represents only the third confirmed interstellar visitor in recorded history, following Oumuamua in 2017 and 2I Borisov in 2019. But unlike its predecessors, which were discovered relatively late in their solar system passage, we caught this one early, giving us months of observation time that could unlock secrets about the universe's infancy. Mind-blowing statistics. 3I Atlas travels at 58 kilometers per second, fast enough to circle Earth in 12 minutes. This makes it the fastest interstellar comet ever observed, nearly twice as fast as the famous Oumuamua. To put this in perspective, if you could somehow board this cosmic bullet train, you could travel from New York to Los Angeles in just 4.5 seconds. Hubble's Space Telescope observations reveal the comet's nucleus ranges from 320 meters to 5.6 kilometers in diameter, potentially making it significantly larger than initially thought, and up to 10 times bigger than Oumuamua. Recent estimates suggest it's closer to the larger end of this range, making it roughly the size of Mount McKinley, hurtling through space. Using cosmic velocity calculations, scientists determined this comet could be between 3 and 11 billion years old. Recent findings suggest it could be as much as 7 billion years old, making it even more ancient than our solar system itself. When this cosmic wanderer began its journey, the Milky Way had half as many stars, and complex life on Earth was still billions of years away from evolving. Despite its incredible age, 3I Atlas displays active behavior that shouldn't be possible. Pre-discovery observations showed the comet's coma had grown from 13,040 kilometers on June 21st to 18,760 kilometers on July 2nd, 2025. That's expansion faster than Earth's diameter in just 11 days. Most comets burn out after just a few thousand years. Yet this ancient wanderer is more active than objects a fraction of its age. Recent spectroscopic observations reveal something deeply puzzling. 3I Atlas shows no detectable gas emissions, despite having a bright, active coma. This defies everything we know about comets. When ice sublimates to create a visible tail, it should produce detectable gas signatures like water vapor, carbon monoxide, and methane. Where are they? Some scientists suggest we might be witnessing the sublimation of exotic ices that don't exist in our solar system. The comet's orbit takes it on a remarkably convenient path through our solar system, passing relatively close to Venus, Mars, and Jupiter. For a random piece of ancient debris, this trajectory seems almost deliberate. It's as if something designed the perfect grand tour of our planetary neighborhood. Impossible preservation. How does something survive 11 billion years of cosmic radiation, micrometeorite bombardment, and gravitational chaos while maintaining both structural integrity and active behavior? During its journey, it would have been exposed to temperatures near absolute zero, bombardment by high-energy cosmic rays, and gravitational perturbations from countless star systems. Unlike the tumbling Oumuamua, 3I/Atlas maintains remarkably stable brightness with only minimal variation over its 29-hour rotation period. Spectroscopic observations show it has a distinctive reddish color, similar to outer solar system asteroids, but its composition remains largely mysterious. The comet follows one of the most extreme hyperbolic orbits ever measured, with an eccentricity of around 6, perfect for traveling between star systems. It will make its closest approach to the Sun in October, remaining at a safe distance of at least 1.6 astronomical units from us. How is this possible? Ancient radioactive isotopes from the universe's violent youth could be powering an internal furnace, generating heat for billions of years while conventional ice would have died eons ago. What if 3I Atlas formed during a brief window when the early universe had wildly different physics? When heavy elements were rare and cosmic conditions allowed for impossible preservation, could this be a deliberately engineered vessel designed to survive intergalactic journeys? 3I Atlas marks only the third interstellar object ever discovered passing through our solar system. Right now, telescopes worldwide are racing to gather data before it disappears behind our Sun, including radio observations at the SETI Institute's Allen Telescope Array, searching for any artificial signals. The global scientific response has been unprecedented. Ground-based observatories from the Atacama Desert to Mauna Kea are dedicating precious observation time to this visitor. Amateur astronomers, using backyard telescopes, have captured stunning images showing details that rival professional equipment from just decades ago. The European Southern Observatory has coordinated a massive multi-telescope campaign, while Chinese and Russian space agencies have also joined the international effort. The big questions: if it's naturally formed, how did it survive 11 billion years while remaining active? Why does it show dust production without corresponding gas emissions? Is its convenient survey path through our planetary system purely coincidental? Could it be carrying microbial life from ancient star systems that evolved under different cosmic conditions? What secrets does its composition hold about the early universe when heavy elements were scarce? Are there thousands more of these ancient wanderers crossing our galaxy undetected? What's the most interesting thing you learned about 3i Atlas today? Drop it in the comments below. And if you enjoyed this cosmic journey, smash that subscribe button for more space content.